Okay, so cycle. What is a cycle?
One on and one off.
No, that's a pulse.
One compression.
A compression and a rarefaction, or one vibration. Okay, so the crystal is gonna vibrate and it's gonna turn off. Okay, so those vibrations are the compressions and the rarefactions. Okay, so this is our cycle. Okay, multiple cycles make up a pulse. Okay, and a pulse is composed of an on and an off time. Okay, so how do we figure out the size of the pulse? Well, we start with a cycle. How do we measure the space it took here? What measurement is that? Wavelength, okay? So we're gonna do space down here, and then we're gonna do time up here, okay? So our space is our wavelength. How do we measure the time? Period. I got my first passing student for the ART today.
Is it Raquel?
Raquel already passed.
Oh,
Yeah, this is Emily. You guys want to look at the little tiny one? She's a little kid. Well, it's Emily, because it's spelled like A. Okay, all right, so we measure the distance or the space, and we measure the time of a cycle, okay? Then, we're gonna measure the on time. So what measurement is the on time? No.
So time is the period.
pulse duration?
For length, for space.
Oh, SPL?
SPL, spatial pulse length. SPL. The spatial pulse length. And in time, what is the measurement? Pulse duration. Pulse duration. Okay, now, from here to here is what? The PRP, which measures time, right? Pulse repetition period. Okay, period, pulse duration, pulse repetition period, they're all time. Okay? So they're measuring, so these two are measuring the same cycle, right? Except that one is measuring space, the other one is measuring time. We're measuring the pulse. These two units are measuring the same thing, only in space, which is SPL, and in time, which is a pulse duration. And this one is measuring the entirety of the pulse with one on and one off. Okay, so that's our pulse repetition period. Now, if we do this, if we measure all of these, what is that measurement called? Frequency. Okay, so let's say that that's 1 microsecond. These are pulses that are repeating, right? So what is that called? Pulse repetition frequency. And in this example, what is our pulse repetition frequency? 3 megahertz. Our PRF is 3 megahertz. Okay, so we went from the individual cycle to the number of pulses that the transducer is emitting per a given amount of time. A little bit clearer? Yeah? You sure? Time and space. Those are the two measurements, okay? Time and space.
So then period and then pulse duration and PRP, those are all time.
Time, yes, that's correct.
And then wavelength and SPL.
Space. That's exactly right.
So duty factor is the period divided by,
No, not the
no,
period.
not the period, the wavelength.
Nope.
No?
Pulse duration.
Oh, pulse duration
Okay.
divided by.
So does everybody have this?
Yes.
Yeah? Rihanna? Yahaira? Yeah, miss it? Okay, we're gonna erase this. Now we're gonna focus on one pulse, okay? Okay, so we're gonna define everything and then we're gonna put them into use according to depth, okay? So we're gonna zoom in on that one pulse. Okay, so from here to here is our what? PRP.
How about a quick question?
Yes.
The PRF space with time?
So it's frequency. I guess, it's amount of space per time.
In space also goes kind of like
In between.
Yeah,
Like,
yeah, so it's just a summary of how many events are in that measured time. Okay, so like if I say this measured time is 1 second, our frequency is gonna be 1 hertz.
okay.
So like the PRF is kind of like the overall, it's like the sum of everything,
So
of all the
you're-
pulses together and the given amount of time.
Okay.
Yeah.
Thank you.
Okay, so this one is our PRP, right? And what is our PRP measure?
The start of one to the start of the next
Yes.
pulse.
Yes, the start of one pulse to the start of the following pulse, or one on time and one off time. Okay, why do we need an on and an off time?
Give the machine time to analyze the data?
Not analyze, to receive the echo,
see.
to receive the echo. So it's gonna send a pulse, that pulse is gonna travel, and as that sound is traveling through all these different tissues, it's sending back echoes. Okay, so it's listening to get those echoes back. Okay, so from here to here is our pulse duration. What about from here to here? I mean, sorry, our PRP. What about from here to here?
Pulse duration.
Pulse duration. I give you guys the answer. Okay, now we have duty factor. What is a duty? Like, that's my duty.
Like your
Work.
responsibility.
Work. Responsibility taken. But, okay, but it's work. It's a physical action of doing work. Okay, so this is telling us how much work that pulse is doing per the given amount of time, which is the on time or the active time. Okay, so if our pulse duration is 0.3 microseconds, okay, but it takes the pulse a total of 0.6 microseconds, what's our duty factor?
0.5? 0.5?
Okay, so it's gonna be 3 over 0.6, right? Which equals to 0.5, but then we multiply it by 100,
50?
which gives us a duty factor of 50%. So this means that our pulse is active exactly 50% of the time. Okay, now, if our waveform looked like this, so this one would be like 0.2 microseconds, and this one would be like 1 microsecond. Or, sorry, 0.2, yes, and 1 microsecond. What would our duty factor be? 20%. So that means that this pulse was on for 20% of the time, which means that it was off 80% of the time, right? So 20% on, 80% off, gives us a total of 1. Yeah? Yes? Brianna? Yes. Make sure. If I give you an example right now to do, can you do it?
Probably not.
Okay, let's just try one out, okay? Let's try one out really quick.
So the weights or the cycles are the 20% and then the listening time is the 80% off?
Yes, yeah. Yeah, so the cycles, this part
That's what we're finding with the deep.
is the on time. Okay, this is the on time. This is what we need to find out. Because the more sound is applied to the patient, that's more intensity, which means that there's an increased chance for bioevidence. Okay? Alright. So, let's say alright, so let's say that we have this one right here. How do we find pulse duration?
It starts
Times period, right? Okay, so let's say that our period is from here to here is 0.3 microseconds. What's our pulse duration?
Oh, I'm sorry.
Okay, 0.3, then we have 3 cycles, right? So 3 times 0.3,
0.9 microseconds.
microseconds, very good. Okay, so our pulse duration is 0.9 microseconds. Okay, now if our PRP is, let's see. 27.0 microseconds. What is our duty factor?
You would divide 0.9 and by 27.0.
Yes.
Would be
Do it on a calculator, please.
And that's this one in 70 microseconds, correct? Or 27.
27 microseconds.
so it'd be no first.
Okay, yeah, equals. Okay, now we multiply it by 100.
So 3.33.
3.3, that, can't count threes. Okay, so it'd be 3.3%. Okay, so that means that the pulse was on for 3.3% of the total time of 27 microseconds. Okay, that's our duty factor. So is that duty factor high or low? It's low, right? Our duty factor, this duty factor
What
is
would
low.
you consider high, like above 50?
Yeah, yeah, so closer to 100.
Okay.
Okay, so if our duty factor is low, what's our frequency?
What?
1 over 3 point.
No.
Oh.
I'm like, don't find the frequency number. Is our frequency high or low?
Slow.
Our frequency is low, right? Our PRF is low, which means that our PRP is longer. Which means that our depth is deeper. Or more penetration, right? Because lower PRF, more penetration. Yes?
Yes.
Okay, now, what factors are related to PRP? So PRP, so what influences the PRP? Pulse duration. And what determines the pulse duration? Period.
Period. Poop.
I had a student when I first got there, she was like, period. I'm like, huh? Like, what do you mean? I'm like, okay, exclamation. Yeah, that's funny. And then she would say bussin'. I was like, I don't understand what that is. It's bussin'. Like, what?
Oh, my son.
Yeah, I feel so old.
Bussin', Mom.
Yeah.
As long as it's not mid.
Right, that's why I saw it. They're like, you're acting like a beta today. It's like, shut up. That's like talking about that.
Oh, no.
Okay, so PRP is related to the pulse duration, which is related to the period. Okay, so if our period goes up, what happens to our pulse duration? It goes up. And what happens to our PRP? It goes up. Beautiful. Okay, if they go down, the period goes down, the pulse duration goes down, and the PRP goes down. Okay, these three are directly related. Okay, but PRF and PRP, what relationship do they have? Inverse and reciprocal, okay? Okay, so if our period goes up, what happens to our PRF? Goes down. If our PD goes up,
Down.
our PRF goes up. If our PRP goes up,
Down.
our PRF goes down. Okay, if our PRF goes up, what happens to the PRP?
Goes down.
It goes down. If our PRF is 3 megahertz, what's our PRP?
And
One.
our PRF,
One.
1 microsecond?
Mm,
If they're inverse and reciprocal, what's our PRP?
so 1 over 3, I don't know. 3 over?
You have it, Brianna? Nope. Okay.
oh, you're right.
So 0.33? 0.3.
.3 microseconds. Do you guys understand how we got that?
Yes.
No? Okay. Alright, so the reciprocal, okay, so let's imagine that whole numbers will always be written like this, right? 3 over 1. Okay, the reciprocal means the flipped, right? So it's 1 over 3. So if you put in your calculator, 1 divided by 3, what do you get?
0.33.
Huh?
0.33.
0.33, right? Okay, but we're just gonna leave it at 0.3. So 0.3 microseconds, or you could just divide it the old-fashioned way, which is 3, and 3 doesn't go into 1, so we have to add a decimal and a 0. 3 goes into 10 3 times. 9 minus 10 is 1, we have a 0. 0.33.
Did you get that because the reciprocals, right?
Exactly.
Okay, so you always get that one.
Yes, yeah, so it's the same thing. If my PRF is 10 megahertz, what's my PRP?
So it's
1 over 10?
10 over 1, so 1 over 10, which gives us
Point 10? Point 1.
0.1,
Oh, 0.1, I'm sorry.
0.1
I'm having an Emily moment.
microseconds.
That's the question I was asking about earlier too.
Okay. Okay. Now, does everybody understand the reciprocal relationship between PRF and PRP? So if you know the PRF, you can figure out the PRP. So what's our PRF? It's 0.1 microseconds.
10.
And
10?
the PRP is 0.1?
10.
How'd you get 10?
It's just reciprocal of it.
So right now it's 1 over, okay, so it's 10, so it's 1 over 10, the reciprocal of that,
10.
10 over 1, which is just 10.
Mhm.
Okay. Megahertz, yes. Okay, now, how does this all relate to depth? Okay, so we're gonna go deep, and we're gonna have shallow. Okay, so if we have deep imaging, so we're gonna do PRF, PRP, and duty factor. Okay, so if we have deep imaging, what's our PRF? It's lower frequency, right? Because our PRP is lower, right? So our PRF is lower, but our PRP is longer. Okay, and what about the duty factor?
Hold on,
Slower.
lower.
Yes, the duty factor is lower. Okay, so just think about it. So if we have a low PRF, that means that there's less pulses, which means that there's more listening time. Okay, now if it's shallower,
You're right.
our PRF is what?
Higher.
Higher? Our PRP,
Is
Lower.
lower.
shorter? And our duty factor, higher. Cause that means in this time, there was more pulses. And the PRF, or on the deeper structure, there were less pulses. There's less pulses, lower duty factor. Okay, so this is a relationship that you guys need to understand, okay? Don't memorize this, understand it.
It helps when you draw it out like that.
Okay, because if you just memorize this, and I'm gonna ask you questions that you're gonna have to use this chart, but not straight out. I'm gonna ask you, like, which arrow is up and which one arrow is down. Okay, I'm gonna say that I'm gonna have a 3 megahertz transducer. It has XPRP and XPRF. And I have another transducer.
Well, can you
that
make
has-
an example right now?
Sure.
Like that?
Yeah. Okay, so how do we figure out the duty factor?
Pulse duration over PRP.
Pulse duration over PRP. Okay, so I'm gonna say, I have 2 transducers. Okay. One is a 10 megahertz transducer. The other is a 3 megahertz transducer. Which one has a higher duty factor?
The 3 megahertz.
Why do you say 3?
Because the frequency is lower.
If the frequency is lower, that means that there's less pulses, right? If there's less pulses, there's less on time, which means there's less work being done, which means a lower duty factor. Higher megahertz, more pulses, which means there's more work being done, which means there's a higher duty factor. Okay, so that's gonna be something similar to that. But if I say, find the duty factor of a pulse duration of 0.2 microseconds and the PRP of 12 microseconds. 1.66%? So let's call it 1.7%. Okay, then I say, the second one has a pulse duration of 0.6 microseconds and a PRP of 12 microseconds. What's the duty factor?
5.
Huh?
5%.
5%? So the duty factor here is 5%. Which one of these would be better to image the thyroid?
5%.
5%? 5% means it has a higher duty factor, which means that has a higher frequency, which means it has a shallower depth. Okay, which is the thyroid, right? The thyroid is very superficial. Okay, so it's gonna be something similar to this, okay? But I won't remember what I asked you today, tomorrow, so I can't make any promises, okay? I just have the PowerPoints and that's what I base my questions over.
So we are gonna have a quiz on this too.
Yes. Yes. Like live under the assumption that there's gonna be quizzes every day. You guys have any other questions? Yes, sir.
So you said, the deep is less pulses, less words, and lower,
Duty factor.
duty